Hello, it's Jay here again and welcome to another tutorial. So in this lesson we're going to pick up exactly where we left off in the last lesson, and we're going to do that by coming to the wheel movement function. So we'll begin by saying float, and we're going to say underscore feet per hour. And we're going to set that float to equal underscore our current speed, and we want times 5280. Let's close that line off, and I'll explain that figure as we put it into the comments. So we'll say feet per hour equals current speed times number of feet in a mile. And that is exactly what this figure is. So let's come to the next line. We'll create, in fact I'll not bother leaving a line space this time. We'll say float inches per hour is going to be equal to our underscore feet per hour times 12. We'll close that line off into the comments. Inches per hour equals feet per hour times and number of inches in a foot. And again of type float underscore inches per minute is going to be equal to underscore inches per hour divide by 60. And again, let's close that line off into the comments. Inches per minute equals inches per hour divided by minutes in a hour. And we'll come below here, and now we can say underscore our RPM wheel is going to be equal to inches per minute divided by the wheel circumference. And we'll close that line off there. So we'll put into the comments revolutions per, I'll just get rid of that extra T, revolutions per minute of the wheel equals inches per minute divided by the wheel circumference. So that is how we get our revolutions per minute for the wheel game objects. And now we'll leave that and we'll come below and we'll say if open and close brackets inside the brackets underscore moving forward double equals true into the comments. If moving forward equals true, we'll come below here and we want to call this function wheel movement forward, open and close brackets, close that line off into the comments, and we'll put in the comments that we're going to call that function. And we'll just paste that in. Let's just copy that if block. We'll paste that in. We'll change that to moving backwards. And we'll change the comment as well. And obviously we want to call the wheel movement backward function if we are. So we'll just copy and paste that naming convention in. And here we're going to say underscore, and we want front left hub dot, and we want the transform dot Euler angles is going to be equal to a new vector3, open and close brackets. We're going to close that line off. Inside the brackets we're going to say 0, comma, and we're going to say underscore, and we want the steering value, comma, 0. So all we're doing is setting the rotation on this axis, the Y axis, to be equal to the steering value. So actually very simple, and let's get this into the comments. So we'll say front left hub rotation equals, we'll come to the next line, steering value on the Y axis, and we can copy that and we can paste that in below here. And we'll change this to underscore front right hub, and we'll also change the comment as well. So let's just save that off for a moment, and let's have a look at our state. So vehicle idling, I'm actually going to call the steering function in vehicle idling as well, so we can actually turn the wheels while we are stationary. So now we shall actually call the wheel movement function as well. So let's just copy and paste that line in again, and we'll copy and paste that naming convention in as well, and remembering in the comments also. So vehicle idling, we're calling the steering and the wheel movement now. So let's copy that wheel movement line and we'll paste it in everywhere what's applicable. So let's just continue on. And basically it's every state where we're actually moving. And let's actually copy and paste those into the coasting reverse function. We'll need that as well, and let's have a look here. And we'll actually copy and paste that line in for coasting reverse. So if the current speed equals the minimum speed, we'll set vehicle states to vehicle idling. And let's have a look now. And let's copy and paste these two as well. So we could actually do with creating a braking for the coasting reverse. as well. Let's just get rid of that. And this one where we're saying less than 0, let's have a look. We need to change to the reversing function. And again, let's save that off. And let's have a look here. So what we need is coasting reverse. Let's copy from the reversing function this first if block. And let's paste that in. And we had, I believe, let's come up to the top. Let's have a look at the actual floats that we've got. So coasting, slow down, reverse. And let's come down. We need to change that from a plus to a minus. It's not acceleration speed now, it's coasting, slow down, reverse. And we'll change this to decrease current speed by the coasting, slow down, reverse. And let's save that off there. We'll probably actually create another function where if we press forward while we're reversing, we'll actually switch to... We'll probably have some sort of function where we can wheel spin before then shooting off into drive. So we'll work on that at a later date. And we'll actually continue on with the wheel movement. So obviously the wheels aren't going to move at the moment, because if we're moving forward, moving backwards, then we're calling these two functions, and these will actually handle the code that is required to actually rotate the wheels. However, we have our steering in place, and we also have our calculations to work out the revolutions per minute of the wheel. And if any of you have any theories on if there's any better calculations, so I must admit it's been a while since I was at school and we actually learned to actually calculate it. Far too many years for me to care to remember, but hopefully I think that is correct if I can remember back that far. So we should have some sort of reasonably accurate rotation of the wheels, and we'll pick this up in the very next lesson, where we'll fill out these two functions and we'll continue on with this script creation. So as always, I hope you enjoyed this lesson. I hope to see you next time, and until then, as always, bye for now.